Local and Global Sustainability Problems, Cryptocurrency Mining and Its Effect on Our Environment by Carla Falone. Cryptocurrency is a digital currency designed to work as a medium of exchange through a computer network that is not reliant on any central authority, such as a government or bank, to uphold or maintain it. It's acquired through a process called mining, which involves solving computational mathematics problems. Some of the well-known cryptocurrencies are Bitcoin, Ethereum, and Dogecoin. Cryptocurrency mining requires specialized computers with high computation power. They solve a puzzle which is called a hash, which allows them to chain together blocks of transactions. Not all cryptocurrencies need to be mined. Mining is used to verify transactions and creation of new coins, which is known as proof of work. The mined Bitcoin transactions are then aggregated into blocks that are added to a database called blockchain. Full nodes in Bitcoin's network maintain a record of the blockchain and verify transactions occurring on it. Bitcoin miners download the entire history of blockchain and assemble valid transactions into a block. If the block of assembled transactions is accepted and verified by other miners, then the miner receives a block reward in the form of a Bitcoin. All cryptocurrencies are mined in a proof-of-work process. Bitcoin miners aggregate mining systems that consume massive amounts of electricity to mine the cryptocurrencies. Just as gold is mined from the earth using large equipment and machines, Bitcoin mining also uses big systems called data centers. These systems solve mathematical puzzles generated by Bitcoin's algorithm to produce new coins. This is one example of one row of a data center, which may have 100,000 identical rows. These data centers need to manage electrical demands, deal with the heat given off by the equipment, usually have a high server turnover in equipment, need to maintain specific server operating temperatures, and because of the enormous amount of computation power required, it has to monitor the cost of the energy consumption. In 2020, the combustion of fossil fuels to generate electricity was the second largest source of CO2 emissions in the U.S. It accounted for about 31% of the total CO2 emissions and 24% of total U.S. greenhouse gas emissions. It's been reported that Bitcoin uses more electricity annually than the entire country of Argentina, and Ethereum uses as much power as the entire country of Qatar. In addition, studies have shown that the mining of the four cryptocurrencies, Bitcoin, Ethereum, Litecoin, and Monero, is responsible for 3 to 15 million tons of carbon dioxide emissions. One of the main environmental issues that many are concerned about is the use of non-renewable energy resources in the mining of cryptocurrency. This is due to the fact that miners tend to gravitate towards the cheapest source of energy. Fossil fuels, such as coal, are regularly used, significantly increasing carbon dioxide emissions. Calculating the carbon footprint of cryptocurrency is a bit more complicated. Although fossil fuels are the predominant source of energy in most of the countries where cryptocurrency is mined, miners have to seek out the most inexpensive sources in energy in order to remain profitable. In many cases, that means relying on new alternative installations. Until recently, the Bitcoin network drew about 46.1% of its energy from renewable sources. That changed after China's crackdown in 2021. They left the cryptocurrency mining, and it forced miners to relocate to more fossil fuel dependent countries like Kazakhstan and the United States. As a result, the renewable share of the Bitcoin network fell from 46.1% down to 25.1%. Researchers at the University of Cambridge report that most Bitcoin mining, around 42% in 2021, took place in the U.S. The U.S. gets most of its electricity by burning fossil fuels. Kazakhstan, another country that gets most of its energy from fossil fuels, follows the U.S. in accounting for 18% of the world's Bitcoin mining. As a result, two countries heavily dependent on fossil fuels are responsible for the majority of the world's Bitcoin mining currently. Electricity. This is the power that runs the mining systems 24 hours a day, 7 days a week, 365 days a year. Contrary to the popular narrative, desktop computers and regular gaming systems are not fit or efficient for Bitcoin mining. The process can heat up such systems and cause bandwidth issues in a home network. Application-specific integrated chip ASIC systems are customized machines for Bitcoin mining. They are the main infrastructure investment for Bitcoin miners, and the price range is anywhere from $4,000 to $12,000 a piece. Even with such high costs, a single ASIC-equipped governance system generates less than a single Bitcoin. Bitcoin miners have to organize thousands of ASIC systems into mining pools that again run 24/7, 365. The future of Bitcoin energy consumption. While many global provisions are falling into place to eliminate or alter potential greenhouse gas producing industries, Bitcoin has not become popular enough to show up on everyone's radar. That said, there are estimates that Bitcoin energy consumption will rise to 110.53 kilowatts in the near future. That is more than the entire annual energy consumption of the Netherlands. If we look at the rapid expansion of cryptocurrencies worldwide, in 2013 there were 66. In February of 2022, there were 10,397. We can compare the rapid expansion of cryptocurrency to the energy consumption worldwide. In 2019, the global cryptocurrency market was approximately 793 million. 3 years later, it's now expected to reach 5.2 billion, and by 2026, 8.4 billion. In just 1 year between 2020 and 2021, the global adoption of cryptocurrency surged by more than 880%. Digiconomist estimates that the Bitcoin network is responsible for about 114 million tons of carbon dioxide per year, equal to the amounts generated by the Czech Republic. The Digiconomist also says the carbon footprint of Bitcoin, the world's largest cryptocurrency, is again equivalent to that of New Zealand, with both emitting nearly 37 megatons of carbon dioxide into the atmosphere every single year. It also generates a significant amount of electronic waste as mining hardware quickly becomes obsolete. According to the Digiconomist, the Bitcoin network generates approximately 37,000 tons of electronic waste every single year. The main concern over this incremental increase is the impact on health and climate change. Now let's consider the role of higher education institutions to address the environmental problems using cryptocurrency. First, when considering either accepting cryptocurrency for tuition or for donations to the higher education institution, the measured damage to the environment should be a priority consideration. If they then decide to accept the cryptocurrency, the institution should consider a specific action to offset the measured damage. Third, a sustainable cryptocurrency is one with low energy consumption and minimal carbon footprint. They should look into the energy sources of the cryptocurrency they're considering and make sure it uses renewable energy. And fourth, from a financial value perspective, cryptocurrency is highly speculative, widely considered to be a commodity. Accepting cryptocurrency in tuition payments and donation subjects the budget, financial statements, and solid foundation of the higher education institution to be exposed to volatile valuations. These are currently U.S. universities that accept Bitcoin for tuition payments and/or donations. Thank you.